Welcome back for our last two talks about React.js Conf. So far, it's been really good, and the next speaker, is going to talk about something that's extremely interesting, and this is I feel like the future of JavaScript, which is static typing, which for JavaScript is a bit weird because it's a dynamic language. And so being able to have both static and dynamic parts in the language is such a fundamental thing, and it's going to explain to you how to use it with React. So James.
So I woke up this morning way too early because I'm still on East Coast time. And I got on Twitter, and I saw this. On the first day, God created the web. On the second day, God wrote jQuery. Then God blacked out. 3 days later, awoke and invented React. So I just wanted to share that with you. Thank you, Matt, for that. That was great. So my name is James Brantly. I work at AssureSign. We create web-based electronic signature software. And early last year, we had the opportunity to rewrite some of our application with all new technology. And so while we were evaluating some of our options, we decided to choose TypeScript since we are a Microsoft shop, and it just made sense. And in addition to that, React was just becoming popular around this time. I saw one of Pete Hunt's videos, and it just clicked. And so we chose React. And what we found was that both technologies individually were awesome, right? They were great choices. But trying to use them together, I found a lot of pain points, and it was very difficult to make them mesh. However, we made it work. And here we are later. We actually just launched. And everything's working really great. So I'd like to share with you today some of the tips and tricks, if you will, of how to actually take a React application and use it with TypeScript. Additionally, a couple months ago, Facebook released Flow, which is sort of the same. It's not the same as TypeScript, but it has sort of the same goal as TypeScript. So I'm also going to show the same exact demo with Flow as well. So for you guys who don't know what in the world Flow and TypeScript even are, what am I talking about here? I have a couple contrived examples just to kind of give you an idea. So here we have variable x is assigned to 0, variable y is assigned to foo, and then we try to multiply them. And I think it's perfectly clear what the intent here is, right? We want 0 foos. But if we actually took this code and sent it through Flow and TypeScript, this is what we would get. I think Flow puts it pretty succinctly. String, this type is incompatible with number. You can't take a string and multiply it by a number. Now, what's interesting here is that Flow and TypeScript actually inferred the types from the source code. In other words, it took a look at x and said, yeah, this is being assigned to a number. So from here on out, I'm going to treat x as a number. Let's take a look at another example. Here we have an add function that takes two numbers and adds them together. Very simple, right? So in our first invocation, everything works fine, right? We pass in 1 and 2, we get 3, great. In the second, however, we pass in a string 1 and a string 2, and we get back a string 12, right? That obviously isn't quite what we meant. And the thing is, if we were to take this code and pass it through Flow and TypeScript, right, we're good. There's actually no issues with this code, right, because it's perfectly valid code. The actual issue was in my intent. If you recall, I said the intent of this function is to take into numbers. But that's not really represented in the code as it is. So this is where type annotations come in. So what we can do is we can actually go and say, all right, these two arguments actually must be numbers. Once we do that, if we, again, run it through Flow and TypeScript, now we get the error that we want. Again, string, this type is incompatible with number. We can't pass a string into this function anymore. So keep in mind that all of these errors that I'm showing here are actually at build time, if you will. This is not at runtime. This is all happening statically, just from your source code, prior to it ever getting to the browser. And so that's essentially what Flow and TypeScript add. They come in, they statically analyze your source code, and then can tell you of different problems with that. Now, I'm just scratching the surface here on what these things can do. As you can see here, there's all sorts of features. This talk isn't really meant to explain all of the little cool things that these technologies can do, but really rather to show you how to take an existing React application and use these with React. So for that, I have lots and lots of demos. Pretty much the whole rest of the presentation is demos. So to start off, I have sort of a little example application here that I'm going to use. This is our example React application that we're going to convert. Forgive the, I don't know. I wasn't very creative with this. And consider this my cat tax if there's any Imagurians out there. So pretty simple, though. We can click forward and backwards, picture changes. We have a text box here that we can type in an index and go to it, right? Nothing too crazy going on here. So if we take a look at the code, it's basically composed of two components. We have sort of an app component here. We are using link state mixin for the text box. And we delegate rendering of the actual image and the transition and all that to this image viewer component, which is in a different file. We are using common JS modules for this. I'm also using Webpack. It's kind of a funny story. I actually did not ever use Webpack before about 2 weeks ago. And I was like, hey, I should use Webpack just to learn it for this conference. And I get here, and apparently everyone loves Webpack. So I feel like one of the cool kids. I chose wisely. So in any case, the main point here, though, is that we are passing this through the JSX loader so that we can use JSX in our application. So that's pretty much it for the application. Like I said, not much here for the image viewer component. This takes the props, which is just the image index, and then it just shows the photo. So let's convert this to TypeScript. I've actually already copied the, let me make this bigger. Unfortunately, I can't make the files bigger, but I've already copied over the two files into this TypeScript folder. And the first thing we need to do is rename the files to have a .ts extension. This is required from TypeScript. So we'll do that. And again, I am using Webpack here. Now this is slightly different. I'm passing this through a TypeScript loader instead of the JSX loader so that it actually gets compiled with TypeScript. So if I go and I try to, so all I did so far is just take the files, rename the extension, that's it. And if I try to compile this, we get a whole bunch of errors. Mostly, if you actually were to go and take a look at them, pretty much they're all associated with this JSX. So the problem is that TypeScript does not understand JSX. And this is one of the first things I ran into right away when I tried to do this. So there's a couple ways to work on this. So the first way would be to simply not use JSX, right? You don't have to use JSX. It's not required. That's fine. More power to you. Personally, I like JSX a lot. I think it brings a lot to the table. I want to use JSX. So option number 2, we could take TypeScript, fork it, make it understand JSX. There have been 2 attempts at this that I know of. One never really got released. The other one did get released, but it is a version behind, and it has a slightly modified syntax. And I have a link to it at the end of this presentation. You can go take a look at it if you'd like. But in my opinion, at least, it's not really ready for prime time. So there is a third option, and this is going to be my first controversial point, I think, in the presentation. So I have sort of a hack that I'd like to present. I would be the first to admit that it's a hack, but it's a hack that works really well. We've been using it, like I said, for, I don't know, like 8 months now, and I don't know, I like it. So I would like to kind of give a quick overview, though, of the basic concept here. So here we have some JSX. Again, TypeScript doesn't actually understand this, so we need to make this into something that TypeScript isn't going to puke on. That's easy enough. We put, make it a string, right? So now TypeScript thinks it's a string, no problem. However, we don't really want TypeScript to think that this is a string. We want TypeScript to think that this is a React element. So what we will do is put a little bit additional wrapper around that. We'll just say React.jsx, and then it's a function call. We pass in this string. Now, keep in mind, this does not actually exist, right? I'll show you exactly how to do this, but basically, I'm telling TypeScript that this exists, even though it really doesn't. So believe me, TypeScript believes me, you know. So that's kind of how we decorate the JSX. So at this point, TypeScript's OK with the JSX, especially like if you're in an IDE. That's really why we do this. So if you're in a TypeScript-aware IDE, it's not like throwing squigglies at you and things like that. And then we can add a pre-compile step where we go and we basically scan the source for these tagged, if you will, JSX strings, and we convert them using the, essentially what JSX loader does, right? Using the React tools. So we convert all those into create element calls, and then once that's done, then we give it to TypeScript, right? Because create element calls, TypeScript's fine with those. There's no issue with those. So that's sort of the basic kind of overview and concept. So I'll show how to actually do that. So we'll come here to this JSX. Let's just say React.jsx. I've prayed to the demo gods that nothing gets too bad today. There's quite a few things that could go wrong. OK, so there we go. So now if we try to compile again. By the way, this is going to be sort of a trial and error on the compilation stuff, because this is pretty much how you would do it if you were trying to do this yourself. So fix that issue. Run again. OK, what do we get next? Cannot find name require. And also at the bottom, cannot find name module. So what this is referring to is the common JS calls up here at the top. TypeScript supports modules. It supports something, they call it external modules, but it's basically like a common JS type of module system. It just has a slightly different syntax. That's it. All we have to really do is say, instead of var React, we just say import React. That's it. The other thing is you don't have the module available, so you just say, instead of module.exports, you just say export equals. All right, so just same concepts, just slightly different syntax. Do the same for our other file. And there we go. So again, let's try to compile. Oops. Cannot find external module React add-ons. So if we come here, we can see that we're trying to require image viewer, right? TypeScript has no issue with that. It sees the file, it can read it, we're good. However, this top-level module, React add-ons, TypeScript has no idea what that is, right? And it needs some information so that it can kind of provide it needs to understand the shape of whatever it is that's being imported so that it can actually provide some intelligence around that. So this is where TypeScript definition files come in. And definition files, you can think of them sort of like C header files. They just explain the shape of in some external API where we just kind of say, TypeScript, trust us, it's there, this is what it looks like. So the way that we do that, I already have some definition files here. I have the React.13 definition file. Myself and two other guys from the Type React project worked last week to try to get this in before the conference, so we managed to do that. I also have this React.jsx definition file, and this is where I'm actually tricking TypeScript into saying, yeah, this JSX function really, it's there. So I have these two definition files. I also have this underscore references file. This is just sort of a convention in TypeScript to say, kind of put all these together. So you have one place where all your where all your definition files are. So now we just need to basically make sure that we're referencing these definition files, and it's done through this sort of this comment syntax. So I'll just reference my underscore references, and we'll try this again. OK, great. So everything compiled. Let's try to actually run this. No. Told you. see if we get an error. Undefined is not a function. Oh, perfect. Actually, yes. All right. So if you recall, we did this React.jsx thing, right? I told TypeScript it existed, so TypeScript happily compiled, but I never actually, it doesn't exist, right? And I never actually did anything with it, so the browser's trying to run React.jsx and saying, yeah, that doesn't work. So we need to actually add that pre-compilation step in. And again, that's done through Webpack, so I'm just going to come to Webpack here, and I'm going to add an additional loader. I'm going to chain it onto the TypeScript loader. It's going to call this ts.jsx. You read this from right to left in Webpack. So first it's going to go through ts.jsx, then it's going to go through the TypeScript loader. So let's try this once more. And there we go. So our application's running. Now, thank you. The problem is there's not a lot of intelligence here. So if we take a look at this file, for instance, we're calling react.createClass, and we're just passing in an object literal, right? Everyone's familiar with this. TypeScript doesn't, TypeScript sees an object literal and it thinks it's an object literal. It doesn't understand that there's like, okay, yeah, there's some functions on here, but that doesn't mean it's like a class, right? So we need some way to kind of convert this into something that TypeScript thinks is really a class. And it just so happens that with .13, that's what we get with React, right? This is the whole point of all the pain with .12. So thank you, Sebastian, for pushing through, because you're making my life much easier with this. So in fact, we can just go right through the blog post. This is pretty much my presentation, right? This blog post. So plain JavaScript classes, EX6 classes, perfect. Class, hello message extends React.component. Okay, try that. All right, and then classes have slightly different syntax, right? So we just need to kind of come in here and change a few things. So prop types, if we actually go and again take a look at this. All right, so yeah, this is how you add prop types, right? You can just kind of go to the bottom and add it. All right, so we'll do that. So image viewer, prop types. All right, so there we go. That's got prop types, get default props. You know, so hey, you can do it this way, or ES7 plus property initializers. Guess what? TypeScript has this, so we can actually use it. So we can just say static default props equals this thing. All right. And then the render function, like I said, just slightly different syntax for classes. All right. And there we go. Now, the cool thing about this is that now TypeScript understands that things like this, for instance, this refers to the class and so forth. We do need to add one more little bit. So we need to tell TypeScript to say that, okay, yeah, state looks like this, props look like this. So we do that through generics. So in this case, we do have props. We don't have any state. And I saw a slide earlier that basically said, yeah, a React component is kind of it's like you can think of it as a function, takes props, state, and then returns something. Well, it's not quite that, because I think there's context, right? There's also context. Go Google it. So we actually need to specify the shape of the context as well. In this case, we're not using it, so we just say any. So I need to define what props actually looks like. So I'm going to create a quick interface here. And it just says that props has an index, and it's a number. So I believe that particular one is probably good. So let's try to go compile. Man, that clock goes down quick. All right, so it compiled. I think we're probably good with this. So if we go back to app.ts, I needed to basically do the same thing here. For time, I already did it. So I'm just going to kind of pull that in. Now, all I did here was just change this to an app, right? I did create a state interface that has the photo index, which is a number, input text, which is a string. Now, there are a couple things I need to talk about here, though. One is the mixins. If you go back to the blog post, you will see mixins. We will not launch any mixin support for ES6 classes. So this is my second controversial part part of the presentation. And I've been trying to figure out how to say this without getting in trouble. You may want to consider not using mixins, basically. And I feel somewhat confident saying that because I've actually seen members of the React core team say pretty much the same thing. Basic idea, I don't think there's anything inherently wrong with mixins, like philosophically. But the problem is that React's mixin system is very specific to React. So there's all sorts of magic that happens with chaining the lifecycle methods, for instance, and merging the return values of different things. And there's just all sorts of fancy magic that happens that you just really can't do outside of create class. So yeah, so just a thought. In our case, I'm going to get rid of the mixin. And so I just need to clean that up real quick. So instead of the whole value link thing down here, I'm just going to say, value equals this.state.input text, right? Nothing too fancy. And then we get some cool stuff here. We can say, on change, right? We need to do a change handler. Well, instead of making a new method and everything, we can just say, we can use fat arrow. And we can just say this.setState. So, I don't know if I need to make this bigger. There we go. E.target.value. All right, hopefully everything looks right there. So this is just ES6 fat arrow syntax. So there we go, mixin gone, great. All right, so now I think we can try compiling again. Oops. Aha, so this is where we start to get into some of the actual benefits of TypeScript. So what this is complaining about is it's basically saying, look, this input text, you're saying 1, but up here, we're saying it's a string. So, which is it, right? It should be a string. Now, this might not seem like a big issue. This was obviously purposefully left in here. And this was, I guess, a bug, you could say, of the original application, even though it didn't actually cause any issues. But, implicit number to string conversion can cause bugs, right? So it's kind of nice that this was able to pull it out. So if we fix that, run it, should get another one. Hey, guess what? Same thing right here. We can't take input text, a string, and subtract 1. So we'll just put a parse enter on that. There we go. And let's try actually running this. And there we go. So now that everything is kind of, so I already showed state, right? So TypeScript actually understands that this.state needs to look like this certain thing. It also understands that props need to look a certain way. So for example, this image viewer index, I'm passing in the photo index, which is a number. It's supposed to be a number because I said so over in my interface over here, right? So if I were to change this and say, OK, let's make it a string instead, and try to compile that, it's going to come back with an error, right? You can't pass in a string to this prop that actually takes a number. So again, remember, this is all compile time. Gives you all sorts of nice, useful information. So need to switch over real quick to Flow. Now, Flow will actually go a lot quicker, thank God, because it has native React support. So first thing we need to do is do Flow init. And that creates a Flow config file here. We can actually leave the JSX extension. Flow understands that just fine. And if we were to go ahead, we can start a Flow server. It just runs in the background, checks the code. Hey, no errors. OK, well, that's not actually true because it's not actually looking at the files. For Flow, you need to annotate your files that you want to actually have checked. So there is a little syntax. Throw at the top. All right, now let's try. OK, now we get some errors. Look at that. Required module not found. Same exact error that we had in TypeScript, right? Flow doesn't know what this module is. So we need to tell Flow about it. We're going to do that slightly differently. Flow does have the concept of definition files, but we're going to do it slightly different here. We're just going to say, we're just going to point Flow to where React actually lives, so we can actually go and see it. So that handles that error. The other one is return missing annotation. So this is referring to this render function. And basically, Flow requires, at module boundaries, Flow requires everything to be annotated. So remember the whole type annotation things. It's just a requirement of Flow so that you can be explicit and so that Flow can do better things when you're talking about like importing modules and so forth. So all we really need to do is just add an annotation to this render. There we go. So let's try doing this once more. Yeah. Thank you. All right, no errors. Great. So we can run this. So this is, again, we have the Webpack thing, and this actually looks identical right now to what we were originally running. And we get an error. Basically, this is a Webpack error saying that, look, the JavaScript you gave me isn't valid. I have an unexpected token, this colon. And that's referring to this type annotation. JSX doesn't actually change your source file like TypeScript does. So what we actually need to do is have some way to pull these type annotations out of the file prior to giving them to Webpack. And that's done through the JSX loader. So if we go to our Webpack config, we have this JSX loader. We can just say strip types. So now if we run it, perfect. And we can run the server, make sure it actually works. Great. So now that's it. I mean, at this point, we're basically fully integrated with Flow, so much faster. And then to kind of give you some of the advantages that you can actually get here, let's talk about props first. Flow understands that this.props is basically a merge of prop types and get default props. So in this case, it says, yeah, OK, you got index as a prop type. It's a number. I got it. So if I were to, for instance, try to come in here and say, var a is a string and assign it to this.props.index and try to run that through Flow, it's going to come back, hey, you can't do that, right? You can't assign a number to a string. So it understands props. In addition to that, just like with TypeScript, it understands the props in the JSX. So we could do the same sort of thing where we came over here to image viewer and change this to a string instead of passing a number. And again, get an error. So we get automatic prop checking just out of the box. Similar thing with state. It understands that this.state is basically the return value of getInitialState. However, there's a caveat here. It goes back to mixins, actually. So if you have mixins, then basically this.state is any, because Flow can't understand. It doesn't know what the state actually is because mixins can add the state in. So this actually only works if you don't have mixins. So if you don't have mixins, then you can basically come in here, kind of the same demo of RA, is a string and try to assign it to this.state.photoIndex, and that's gonna return an error. Now, one thing is that it's not going to return an error on this input type like TypeScript did, and that's because it's actually, as far as Flow is concerned, this is the type of input text. So we can either fix that by just changing input text, and then it'll know the correct type. We can also kind of do a similar thing where we say, we make sort of a new type here, very similar to TypeScript. We say, photo index is a number, input text, it's a string. And then we say, OK, well, this getInitialState function needs to return state, right? So if we were to try to run that, it's going to come back with, it's going to come back with an error regarding the mixin, but you get the idea. So that's Flow. Much easier to integrate with React, much quicker. So in the last minute, so yeah, which one, right? Flow or TypeScript? Well, I think the answer is extremely clear and obvious, right? I mean, Flow, right? I mean, no questions asked, right? No, in all seriousness, though, it's actually a much harder decision, I think. They're both quite good. So TypeScript, some strengths of TypeScript, works on Windows, whereas Flow doesn't. So if you're a Windows shop, well, you don't really have much of a choice. TypeScript is also much more mature. It's been around a lot longer, and it has a crap ton of definition files for every library under the sun. So now, Flow, on the other hand, especially for this crowd, a huge plus is the native React support, right? You don't have to do anything really special. It understands JSX, it understands props, it understands state. No big deal. Things like Windows, that sure doesn't have it now, but it's coming. Definition files, it should work in the future. It's on the roadmap. And then I also found that Flow had much better type inference. So for instance, early on, I had the add function. I actually had a really hard time coming up with an example for that because Flow just kept catching everything I threw at it, even without type annotations, right? It was just so aggressive, and so it was pretty awesome, actually. So they both have their strengths and weaknesses, and I think they're just going to get stronger and converge more than diverge as time goes on. So I think they're both great choices. Here's a bunch of references to everything, including this presentation. Typed React, I didn't get a chance to talk about, but if you need to use mixins and classes in TypeScript, go check out the Typed React project. It'll help you to do that. And then lastly is the TypeScript fork. So that's it for me. Thank you.